Shall we start? Yes. Okay, so coming back. So after we have secured everything by the authorization and authentication, then comes logging. So logging is an important feature of security because this helps in doing postmortem analysis. This helps in postmortem analysis. Once the things are done, so who has done the wrong thing or who has done the right thing, so you will be able to do. So in SQL Server, it has a minimum logging capability. SQL Server does not have quite a huge logging capabilities. It only logs failed requests and things like that. So we have some third-party tools that you can use from Redgate or anybody which can help you out in auditing. Okay, but auditing we do it basically access, security, and activity. Access is what SQL Server does. Security and activity related is where SQL Server leaves it to the applications to basically log their own base. We can have third-party tools like Redgate or something which can be used for this also. Then comes auditing. This is also used for the postmortem analysis only, or alerting. Basically, before the incident to occur, if there is any anomaly, we audit each and every activity that is done in the database, every insert or everything, and then we look for anomalies. So, for example, I'll give an example. Say like an attendance, right? Every hour at this time frame, you can expect a load of this much. But what if in the middle of the hour you have a load? That is an anomaly. So then we alert. There are two ways, either to obstruct or to alert. Okay, depending upon the severity of that. Most of the times, applications does not restrict the entry. They will alert. So in the past, there's an abnormal activity has happened. Please look into it. There's an email alert that goes, or nowadays everything is phone-based. Notifications are going out. So people act. The ops team again, the DBA team or the ops team, they act on it. They'll see what kind of a level, what kind of threat is it. Is it just some teacher or somebody who has been stressed out all this doing right now? That's fine. So be it. Fine. It is just an analysis that people do at some point of time, whether has it come from a regular user or not. Okay. So that's how we audit. Again, I'm not going deep into this because this is regular one that we do every time. So we do audits at a server level, at a database level, and at an activity level. Server level means all the activity that is happening at the server, in the server, not just the database activity. Any activity that is happening at the server level will always be monitored and alerted. Okay, that is done by the cloud ops team or the DevOps team. Second thing is at the DB level. That's where DBA team comes into the picture. They will look into it and they will handle that part. And third thing is the activity level. This is the site activity. Basically, any application or any website that is running towards that, they will also log some activities around that. Their activities, whatever have been performed through them, and there's an alerting mechanism even with that also. Okay. Now, this is a specific feature. EDE is a very specific feature of SQL Server. For any database, we take backups every day, right? When we take backup of the DB, the backups have data. Generally, in a general scenario, what as a thumb rule, what we do is, if there is high transaction that happen in the database, think of like Amazon or somebody, right? They take daily full backups, and the regular one they take weekly full backups are taken. In a case like we have a weekly backups itself. So backup is taken mostly on Saturday nights. At Sundays, most of the places it is holiday or the activity would be low. So Saturday night are the time when we generally take the DB backups. Now on a Monday or a Tuesday, nobody is hacking the DB, but they got hold of the backup. Now, do they have the data with them or not? Even though it is 2 days before data, they do have the access of all the data. That is also a threat, right? So, in order to counter that threat, what SQL Server has come up with, it has come up with a concept called TDE, transient data encryption. What does it do is, if you enable this, even the backups are all encrypted. Even without the keys, nobody will be able to restore that DB. Even though you have a backup, it is of no use. You can't restore it anywhere because you can't query the backup, right? Nobody can query the backup. You have to restore that backup into a DB and then kind of query that with whatever data you want. That restoration will not happen until you have the key with you. So this is one more feature that SQL Server has brought in, transit data encryption, so that the backups itself also can be encrypted. They also will not be stolen. Okay. Then comes our data.
Steps can be elaborated. Is that possible?
Sorry.
Previous slide. Steps. I see some steps.
Yeah, it is just how you have to do it in the SQL Server, right? You have in the SQL Server, you will have something called as a master key, and every database you will have a master database key. So that master keys are important. You store that master keys, and when you want to restore, you need to give the location of the master key and your DB key so that you can restore the DB. There is one more layer of security feature that we do it. It is an overhead because you cannot just like that restore the DB at any place. You will have to have these keys in place, look at them, and then do it. It adds one more layer of security, but adds one more level of work for the DBS to restore it at any place. So here comes our data. Now we have come to the actual part of the data security. Data security, there are two things, as we all know: data in motion, data at rest. Right? Data in motion. When we talk about data in motion, for a database, data in motion is when the data is coming through from a different server to the DB, whether be it your web servers or app servers or whatever. Whether you have any other server through which you have a batch job which is sending out that data, cron job, whatever that is. So that is where the data comes through here. So, and most of the times it is to server communication within the company or within the firewall. You don't expose your database outside of the firewall. Your web servers can be exposed through the firewall, but your database is always behind your app servers, or behind your web servers, or behind your application servers, or behind your DBs and everything, right? So your database is kind of secured in one way, that it is behind everything. So the communication between the servers, generally we encrypt that using any of our SSL certificates. So that will give us a good amount of security. Right? On the website, you will have to have your own other ways of security of data coming from your user to the web server. That again, there are different ways that you can secure that. Now that is not what I am talking about here. Once the data comes from the web server does whatever the processing it has to do, or the app server, or your batch jobs, or whatever, all your application, gamut of applications that you have, all of that does the processing, and at the end it is trying to push the data into the database. So from that server to your database server, that communication is, if you put the SSL certificates on that, so that is the data in motion. That is the way that we secure the data in motion. High-end enterprises does that. Low-end enterprises, they don't even care about that. They only do the web server hardening, and the secure data comes to the security is handled only from your website to your web server. From web server to the DB, since it is within the DMZ, within the firewall and everything, it is, so they kind of leave it also. But that is only for small set of applications where they are internal and not of much importance. Data is not of much importance. So those are the ones that they leave it. But data of high importance and everything, we do put an SSL certificate so that nobody can come through that route. Nobody can hack your web server, and from web server they will not be able to get that data. Right? Now for the data at rest, that means once data is entered into your database, entered into your tables, how do you secure them? So for that we have talked about TD encryption already. So we'll talk about data masking, row level security, and encryption. The last part is the encryption. That is the strongest of all. Okay. So data masking. What is data masking? Anybody? Data masking, as you might have seen it in many of the sites. No? Whenever your credit card numbers are shown on your bank sites, how do they show? Credit card numbers. Only last 4 digits are shown. Rest everything is XXXX, right? Even when your name, when it comes, like my name is Srikanth Jiddu, yes and H will come, everything will be XXXS, right? What is that? That is data masking. What they do is they are masking your data so that if you know it. If you don't know, you don't know it. Right? If you know your credit card number, last 4 digits you will be able to get, okay, yeah, this is my number, fine. But nobody will be able to use it. But the person who knows it. So that's called data masking, where they mask the data. Means you're just masking it. Now in India we have only the credit card numbers that are getting masked. But when you go to either UK or US, right, the date of birth is also sensitive information that gets masked out. Right? Most of the guys are okay with giving their year of birth. Nobody is okay giving the date and month. We are okay, we give everybody our date of birth. We don't care much. But there are some people who does not want that. Okay? So that is one PI information. Name, address where you live. That is also in some case a PI information. Your health information. Everywhere in the world health information is PI information. So they mask it. There again levels. How to do it? Masking is the first level. Where that means, so for masking there are two ways that you can mask the data. Okay. Data masking, there are two ways that you can mask the data. One is called as dynamic data masking. Other thing is static data masking. What is the difference? It's evident there, but just by the word you can tell the difference. Dynamic masking means the data in the tables is not masked. It is just like that. Only when it is shown up on your pages or anywhere, it is shown. Either in your reports or your PDF documents or on the websites, it is masked and shown. But data at the database is not masked. It is the actual value. But when you go to static data masking, that is masked. That means data at rest is also completely masked. Another way of how you guys can ask me, sir, why do you need static data masking? That means my data is all masked, nobody will be able to read it. What is the need of it? The need of it comes when you are moving data from prod to the local databases or to dev environments. When you are moving that data, right? You don't want your PII information to be moved from your production database to the lower environments, right? But you want your lower environment team to be able to test all the scenarios of your data, your production data, so that they can create the code pretty better, right? So how do you do that? That's how we use static data masking. So what we do is the production data is masked, or we call it an obfuscation process. It's called as data obfuscation process. We obfuscated the data. Best example is Srikanth Jiddu becomes ABC XYG. But my properties are all there. Whatever the health problems I have, whatever my credit card information or credit card number gets changed. But I do have one credit card. I have made some purchases in some stores. But you can't know that is me. You will know that there is a guy called ABC XYZ who has done these many operations. And whenever you are creating your application or your data analysis or your forecasting analysis, whenever anybody does all of that, they will be able to use the pattern of the data that has been entered. But you will not be able to identify that he is this guy, right? So that's how the static data masking is used. Okay?
But the static data masking says it cannot be reverted to the original
Yes.
data.
Yes, it cannot.
So when it is not reverted back, so you keep it masked, and then what you will do with it?
Once the usage is that you destroy it.
Okay.
I'll give an example. So Srikanth Jiddu has become ABC XYZ. So from production data is obfuscated and given it to the developers so that they can do. Once the development of the project is done, say it took about 5 months or 6 months for them to do the project. So the project is completed. So what is the use of that data now? They want to continue, they can use the same thing.
No, but even to continue, see, when it is masked, if you want to use it, you need to convert it.
You cannot.
No, but when we don't use it, what I will do with that?
When saying you're not using it?
No, data is there.
Hmm.
We have masked it through that static data masking. So I am not using it because in order to use it, I need to
No,
remember.
you don't know my name. See, you don't know that. That is the beauty of it, right? See, Srikanth Jiddu has become ABC XYZ. So you know that there is a guy called ABC XYZ. You are not using my name, but you are using my characteristics. That I have so and so health conditions. So you can use those health conditions to figure out or do whatever the work that needs to be done. But you can't say that, oh, this guy is ABC XYZ, so can I call him and do that? You can't do anything of that sort. But you would know that there is a guy called ABC XYZ who has got all these problems in there, and whatever the work that has to be done for a medical be it a hospital or any other drugs discovery, you have to run some analysis on that. You would be able to use the data. It is a live data that can be used, but you can't recognize that this is this guy. So for that, the static data masking is very, very useful. For all the medical data, take an example of DNA. Best example is DNA. You have your DNA markers and everything given, but you don't know the name of the person. Then what will you do? You can use the DNA for all your protein analysis. You can use the DNA for all of your medicine analysis. But you will not be able to say that, okay, this DNA belongs to Srikanth Jiddu who lives there. So you can't do that. But you will be able to use my DNA to do any one of the testing that are meant to be done, which is the need for the development. Right? So again, before going this, I skipped some very important one, which is called as data classification. Because I've been talking about PII. How does this PII come into the picture? We generally skip this part. Generally, we skip this part, which I have done now also. I've skipped this part, but this is a very, very, very important topic to be covered. What does data classification mean? Anybody?
Classified into different categories.
What categories?
The characteristics based on age, name, data entry.
No, it's close, but not that. Your data classification means you're classifying data based upon what kind of data it is. The classification elements here are public, internal, restricted, confidential, highly confidential. What is the data about? So like VIT name, VIT address. It is public information. You don't have to secure this. And VIT also doesn't want to secure this data. What they might want to secure? They would want to secure your name. Because your name inside the school is secure information for them. They don't want to publicize to others that you are studying here until unless you give them, you tell anybody that I am studying here, or your mark sheet tell everybody. Your mark sheet in one terms is also a PII information, but that's a different story. But VIT doesn't want to do that. They want to publicize it. Right? So how are you marking each one of the data elements? How are you marking? So that is what is data classification. Okay. So it is classifying the columns or the data elements that you have right now that have sensitive information. For all the applications that you have, an enterprise will not have one application, right? An enterprise will have hundreds of applications. And each application will have its own data elements. So each application, each database, not just the database, each application has some data element within it works. Each data element is now classified, saying whether is this data element internal, or whether it is confidential, or whether it is restricted completely, or whether it is highly confidential. Depending upon the data classification, we take actions. Data masking is one of the actions that you take on the confidential information. Okay, but before going there, you first have to classify the data across the organization. Okay, so that is what is data classification. It has labeling and visibility. That first thing is you have to label. You identify all the data columns, data elements that are there in your application. You take them and now you label them with the standards, and then you now have to say for this kind of an classification what I have to do. Okay. So there, what are the ways of classification? Generally, I told you the general way, where I have given you this GDPR. It is General Data Protection Regulation. It is given by the European Union. This is what is mostly used around the world. So you have public information. Public information means that data that can be viewed by anybody. Internal is the data is used internal to the company. What are the internal company? The number of students, or my balance sheet, my expenditures, costs, those are all internal. Within the department, people might be using it. It is not sensitive, that sensitive, but it is internal. Okay? And then your confidential information. That's internal data with restrictions. Only a set of people will be able to access it. That's confidential information. When it comes to restricted, that means it is further more restricted. That means only a handful of people will have access to that. For example, of a restricted data is your balance sheet. A company's balance sheet. Take about any company, any retail company. Right? The company's balance sheet is a very highly confidential information because that has its earnings and expenses. That balance sheet remains highly confidential until it is given outside. If you are a public offering company, till the time your quarterly earnings are given out to the public, till that time it is highly confidential. They will only a handful of people will know about that, where it is and what details are there within that. But once the quarterly results are announced, that becomes public information. So the classification is one thing, and then the time when it changes also is the second part there. Okay? Now when you say restricted, what happens is it has all your PII, PHI, all those information. PII means personally identifiable information which comes with your name, date of birth, address, details and all of that. PHI is personal health information. What kind of ailments you have, what is your RBC count, etc. etc. Okay? And it also comes with your credit card information and all of that are all PII information. Now US government, just for understanding, US government has a different set of nomenclature altogether. They have confidential, secret, top secret. They start with here. They start here and go. There is nothing called public or internal for them. There is only confidential, secret, top secret. That's it, done. Okay? So whenever you have your data elements are there for your organization, or take for example for your application itself, first you need to do a classification of the data elements. Right? Just take an example. If you are creating, say, like an student information system for your college, think about that. You are creating a student information system of your college. Right? Basically, what you'll have all the courses offered by your college. You'll have a list of all students who are being enrolled, or first who are applying and the application process, and then who are enrolled, and then which student is taking what courses, and then you have an attendance, and then you have grades, and then you have reports, the final report cards that are given, mark sheet that are given, right? This is the whole process. So in this whole process, now for each process you have your own set of pages that you create. Now for each set of pages you have different set of data elements. Like for example, for the application system, when somebody is applying to VIT, now instead of the name, address, vagera, what all details do you take? What is his marks in probably the entrance exams? What is his hall ticket number? All of that information are being taken, right? Now you are storing that. Now you have to classify that data elements. Individual elements. What of that? Probably you will not look at the public or internal, you will leave about them. The important part is what data elements in them are confidential or restricted. That you will have to first identify. On all of your data pages, you will have to first identify what are your confidential and restricted data elements on your total system. You first have to identify them, and for each one of them, now you have to determine what kind of security aspects you are going to take on them. On some pages, you will leave them as is. You are restricting them by users, by authentication. Only the dean of the college or only the vice chancellor or those high people will be able to see some. For them, you have to show everything. There is no restricted or confidential. They will have to see everything for them. But others, you will mask them out and then show. Right? Things like that you will have to think about it. You will have to discuss and then do. And here, once your classification is done, generally in a business terms, what happens is, once the classification is done, you go back to your client SMEs, subject matter experts on that, or the client security team basically. You go to the client security team and ask them, okay, boss, these are my PII information and this is how I am classifying this data. And now tell me what kind of these things have to be created for them. What kind of security policies have to be applied on these data elements. So that you will have to discuss with them and then do it. Okay?
So this classification manually need to be done, or it can be done automated?
That's it.
Okay.
Okay. So for most of the cases you do it manually. For most of the cases you do it manually. But for enterprises you have something called as Microsoft Information Protection Policy. Microsoft has come up with its own tool called as MIP, Information Protection Policy. Where with that what will happen is you can give your data elements, because your data elements are common across the complete enterprise. VIT has its own common enterprise. At an enterprise level, you take this element is my confidential information. So no matter that particular data element, like student name is PIA. It has to be masked. Except these 3 pages, it has to be masked. Wherever you are using, it has to be masked. So that's a common rule. Be it used in this application or that application, it is common across everywhere. So you not implement that. It's not just the applications. It's also about the documents that you create. It's also about the documents. It's also about the reports that we create. We have to take care of that also. So Microsoft have come up with one tool where once you classify these ones, if we are using that MIP platform on the whole enterprise, every other it suggests. Now it tells that this is this, so you have to go ahead with this kind of security initiatives for that particular one. So it kind of suggests that it is an enterprise level tool. It has newly come up. It has come up about like a year back. I myself did not have a privilege of working towards that, but this has come up in Microsoft 365. You have Office 365. This is one of them that can be purchased along with that. Okay. This is again here. The initial work has to be. Initial work is again manual. The initial work is manual because there is no automation in here. It can suggest. Most of these tools, what they do, they'll suggest you saying that if it is name, they'll say this is this kind of PIA information. This is PHI information. This is this. They will suggest. But at the end, it is the client's responsibility or the organization's responsibility to agree to that or to say whether it is not or not. So that will have to be done manually only. But once it is agreed upon, it is being used across everywhere in the same norm. Okay. Now we'll come back here. Any questions on the data classification? Okay. But if you have next comes is the how do you handle the classified information? One thing is data masking that we have already spoken about. Second thing is the role-based access. SQL Server has something called as role-based access. This is exclusively for SQL Server. You might have it or might not have it in other database systems, but most of the advanced systems have role-based access, wherein what you can do is you can align a particular row, not a table. A row inside a table you can give an access control. Okay, saying only these particular role or roles can view this data or can edit this data. That means in the authorization and authentication, what we have given a role and we have given the role access on the complete table. A select permission on a complete table or an edit permission on a complete table. This is one step below that. Now you're not saying anything at the table level. Forget about the table. Now I'm going at the row level. A table has 100 rows. These top 5 rows I give access only to this set of rows. Only these rows will be able to update these 5 rows. The next rows, they will not have access at all. Only these 5 rows they will have access. We can do that. That is a feature in SQL Server. But it comes with its own, it is a very good feature. But every security feature that we are going to implement comes with a cost. It comes with a cost. That means every transaction now will have to check for every record whether that user has that access or not, and then verify and then do it. So every transaction, every select or every insert or every select query that you are coming up, be it for your data warehousing purposes, OLAP areas also. Now everywhere this additional check at every record will happen. That's an additional cost. That's an additional cost, but that's the compromise. If we want that highly secure data, the cost of the computation will have to be taken into consideration. Right? That's where this role-based access is this RLS, called RLS, role level security. It is not that prevalently used. I mean, I have not used it in all of my career as of now. I've used only role-based access at the table level, not at the row level. Row level access, people generally don't use it because none of our general applications are not that secure at the table level. Why? Because we design the tables that way. It's not that we don't want that. We design the tables in such a way that every table has a meaning. Right? Every table has a meaning. We don't combine most of the data into one table. We normalize the tables. Even inside the normalization also, sometimes when you have two disparate ones and you want it like that, so we split the data into two different tables. So that you give an access role to that particular table only. You don't give the data in the other table, they will not have access. So we do it at that level. A similar kind of the ones is applied, but at a table design level itself, we take care of it. Okay? Any questions? Then comes the favorite topic of all, data encryption. Now this is the address I just spoke about here. Okay, which talks about every record will have a role that is accessed. A role will be assigned to a person. Again, here is also the same funda. A role is assigned to a person. So we are not assigning rows to a person. We are assigning rows to a role and role to a person or a user.
So you have one full row. What about any single element or?
Right now we have not gone to that level.
Okay.
That where encryption comes handy. Where the whole column you want to.
No, not entire column. Specific element.
Generally we don't go that level, sir. Either it is at a complete column or a complete row. We don't take care of a specific value in that.
Okay.
Because if a specific value is of that importance, that means either the whole row is of importance or the whole column is of that importance.
Okay.
We don't have any scenario in a business terms.
Okay.
We will not have that scenario where only one particular value of a cell is important. So in SQL Server we have something called always encrypted. Again, this is same encryption. You guys have heard about all the encryption algorithms. I am here to tell you how the encryption is used in the real world. Okay. SQL Server has got a feature called always encrypted. That means if your column is highly confidential, where you don't want even the DBAs, to look at the data. That is the difference between data masking and encryption. In data masking, the data at rest is the same. Right? People who have access to the database, like a DBS, they will have high level of access to the database. In some cases, the production support team, whoever is supporting the production, they will have access. Although you access for a JIT, just in time you take access for about like 1 hour or 30 minutes or so. Even in that time, you will be able to query the database and then look at that data. You might not be able to download for security reasons, but you will still be able to view that data. But even if you don't want your users to look at that data, right? Say for example, credit card information, credit card number, which person has which credit card number. Generally, all these credit card companies that we talk about, all the banking sector companies, they don't want them to be seen even by their DBAs. So they will mostly go with encryption. That means data at rest is also encrypted. Even if a DBA wants to query the data, he'll look gibberish. He'll not look at your exact value of the or exact number of your credit card. Nobody will be able to see it. Only that is what is encryption. Now, how does SQL Server implement that? SQL Server implements that with a concept called is always encrypted. That means that particular column is always encrypted using two keys. One is your master key and one is your private key, public key and private key. It uses both of them. The public key is stored inside the SQL Server only, but the private key is not stored in the SQL Server. Private key is stored at a different place. In Azure, we have Azure Key Vault. So all the private keys are stored in the key vaults. Okay. Now, how does if the application wants to show, how does it show? For every data read, what it has to do is, it will go to the key vault, get the private key, get the public key from database has the public key, so it is anywhere there with that. So it combines both of them and decrypts it and then shows the value. So here the cost of the decryption is slightly more. The cost of decryption is more, right? And since the data that is stored in the columns is all gibberish, you can't do searches on them. That is the minus of it. The minus of it is that once the data is stored using any of the encryption algorithms that you want to encrypt the data, you can encrypt it. SQL Server provides you the 512 the encryption is what it provides. You can get SSL certificates also towards that and keep the private key. You have encrypted the data in here. Now, once the data is encrypted, how do you show that data? And most of them use the search. People will have to search, right? For if most of them you search for the user and show the credit card number, that is one way where you show the credit card number by decrypting. So your web application is responsible for decrypting the data. Your web application will get the private key from the key vault and then decrypt the data and then show it onto the application. So that's how they do it. That's how only the application code will be able to show that information. So that's how the data at rest is also completely secure. Your DBS also will not be able to see the data, right? Even if the data is stolen, say for example the data is stolen, somebody took that data, took the backup, he had the TDE keys and everything, he stole the data. Now how will he encrypt it? How will he decrypt the value of that information? If he doesn't have the private key, he can't, right? He just cannot. So that is how secured is this. When you go with an always you encrypt the column completely. So that's how it is secured, right? But what is the drawback of this? We have seen the advantage of it. What is the drawback of this? The drawback of this is you cannot search that column. There are very restrictions on storing that columns also, because that column is not int or a varchar or anything, right? It is a var binary now. It is a var binary column, and you cannot do searches on the var binary column, right? When you go with always encrypted, right? So that's where only in, equal to, and in are the operations that can be done with that. No other between, like, these operations cannot be done. If you give the last 4 digits of the credit card number and then search with that, it will not be able to give you anything of that sort. So you are making the data secure. That is there. But the disadvantage of that is you will not be able to do any of the search operations on them. Okay? It's not just for SQL Server. You go it for any database structure, be it Oracle, be it Mongo, be it CouchDB, or be it DynamoDB. Any database that you go, whether it is RDBMS or NoSQLDB, once you encrypt the data, your data at rest is highly secured, but you cannot do any operations on them at the database level. All the operations have to be done at the application level itself. Okay? Hey, there are some disadvantages with that in SQL Server. You cannot do any bulk updates. Copying data is not, like I told you, right? Nobody can use anything, nobody can do anything of that sort. Only the application will be able to handle that information or show that information, either update or delete or anything of that of the operations. Nobody will be able to do anything. That is highly secure. But then you are handicapped by the database operations that you are doing it. The ease of doing that database operations is reduced. Why is that important? You guys can ask me, sir, why is that important? Generally what happens in a highly transactional database is that there will be a lot of data errors that can creep in because of human errors. In the application, somebody has given a wrong data. Now he wants to update, or there is a business logic that is written wrong. So it has mass updated about like thousands of records. Now how do you do that? In general scenarios, what you do is you create a data script on the database and then update the DB, or correct the data as per the right values. Because it takes time for you to change the application code, test it, verify it, and do it. It might take about a week or 2 time, right? But your data is important. Your reports are going bad. Your customers are again getting they are not getting what they want. So in that scenario, what we do is we create data scripts to update the data in the business, update the data in the database, and then correct it, and you will stop that feature. You will stop that feature so that no more bad data comes in into the application, and the current bad data that is in the application will be fixed using a data script. Now with this you can't do that, because until there's in the application, nobody can read that, nobody knows what is the exact accurate value of it, right? Because it is all gibberish stored there. So that is the problem. That is the disadvantage of it. To some extent, this problem is solved with something called as an enclaves, security enclaves. SQL Server solves a little bit of it using security enclaves. But it is again, what a security enclave here means is that you have a separate dedicated server that is left for doing the crunching. The decryption of the value is done by separate server, which is under the control of the database. So you are giving additional CPU to it. It's like you are giving additional CPU to it so that it can decrypt the data a little bit faster rather than one by one, because database CPU itself is used by many other things. Database itself uses it for many other things, right? Just for decryption, now you are giving it an additional power, additional CPU, so that it can decrypt the value and then do it. That enables SQL Server to use between conditions or like conditions that can be used in there, but that is also limited. You cannot do the SQL script operations in that. That is also another, that is a bigger drawback of it. Okay? Any questions? Then I think we come to the conclusion of it. The conclusion here is that first, how do you do this data encryption, or how do you secure the data in an enterprise? First thing is you need to do the classification. First you have to classify the data as per the needs. Then you identify what is the critical information in that. What is the critical information in that? Then you identify the appropriate data protection techniques that you want to use, whether it's encryption or data masking or what you want to do in that. So you do that first and then apply it. So this is the way that you can secure the data. Okay? Any questions? And then this concludes.
Thank you.
Any differences? You have got any differences? I share the differences with you, sir.
Yeah.
All the differences, whatever I've done about this, is all from Microsoft only. There's nothing beyond Microsoft in here. But I will give these differences to you, sir, so that it can be submitted to you guys again. Thanks. Any questions or anything?
So why do you depend on Microsoft for everything instead of Infosys developing something of it?
We are a service-based company, boss. We are not a product-based company. And we are not that big like Microsoft. Microsoft has been in this domain for a longer time, and their idea is to create products.
But in the current geopolitical scenario,
It is, yes, but Infosys has its own products, not at the OS level or something. We have products on the banking sector like Finacle. We have our own data security platform called MIA.